Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 393. Oops. Minimum sum of array values by dividing array. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about this one. So this one, it's not a 3 hour video. It doesn't have to be. So I spent about 3 hours solving this problem, just to kind of give you some context. And the reason why I point it out is so that you don't, think this is a long explanation. It's not. Most of that is just me solving it live. And I'll go over why in a little bit. But the reason why I want to point it out is that I feel like, I don't want people to think that, I give this advice a lot where, especially on my recent video on how to solve problems and how to attack problems on my other channel. If you want to learn more about that, how to solve Leetcode problems, how to approach them. So on that video, I say that I will take as long as I need. So, and this is as long as I needed, 3 hours, I did do a quick check just to make sure that my strategy was right. And it was kind of right. So, I was going on the right thing. I just kind of had issues with implementation. To be honest, yeah, I'll go over that in a little bit later. But I want to go over I think that, I don't know if, no, I think it is. What I would say the intended solution, which I didn't get until I took a peek afterwards. After I solved it one way, I took a peek. I'm like, oh, huh. And then as soon as I saw it, I was like, okay. And then I didn't look at the details. I just implemented from scratch, and then I proved it to myself. And this is what I'll share with you. Sorry for the long intro. Not that sorry. But I just want to give you some context about this thing, right? And I didn't solve it during the contest. So it's very sad for Larry's rating. But yeah, so for this one, it's going to be... So the intended solution, the hard part is actually not the code, because I actually I saw it, I was like, huh, that works, huh? And then I banged it out in like 2 minutes. I think I had a typo, but, I was just rushing it anyway. So it's not... and you can see that live, kind of, in the live portion of the video is near the end. It's like 3 hours, so like, it's very far in the future. But it's just me typing, so it's not that interesting. So this is this, the idea here is the dynamic programming, and you have to be a little bit careful because, there are two ways to do dynamic programming. And actually, I actually did it another way too. Let me see if I can pull this up actually real quick, right? Yeah, I do have it up. Hang on. Yeah, so let me open this and then just do it this way. Okay, so this is basically my first attempt at you don't need this. This is my first attempt at dynamic programming. It's not right, or it's correct, but it's too slow. So I wanted to kind of just, because I was kind of stuck. I was like, oh, let me just write how would I write the dynamic programming? And this is how I would write it, right? The idea here is that it's kind of brute force in a way, right? So it's just index and used, but in this particular problem, index could go from 0 to n, used can go from 0 to 10, I guess, as the max is m, but it's only up to 10, so that's not bad. So the sum of input states are fine, but the rest is not so good because there's a for loop that goes to n, and so now this is going to be O of n squared times m. So this is definitely too slow. N is 10 to the 4th, even though m is small, it's not great. But just to go over this real quick, all it does is that it keeps track of a sub. For this dynamic programming is saying starting at index with used and values, what is the min cost for the rest, right? Actually, I think I missed the base case, but if used is equal to m, we can return 0. I think that actually just returns 0 anyway, but maybe not, I don't know. Either way, I mean, I didn't actually submit this because it would time out anyway. But yeah, the idea is that, okay, we look at the current item. If this is equal to the n value that we need, which we needed to n array, then we just do this recursive step, and then we also do this other recursive step, right? And then we do a for loop to like, okay, what if we take 2 values, we take 3 values, etc., and then we keep track of the indexes and the values, and so this is pretty straightforward conceptually, but it's gonna be too slow. No bueno, right? We'll get back to this in a second. To be honest, I just want to show you that's how I progressed. But it turns out that there is we can make a small adjustment to it, which is by keeping track of the current. And what is the current? So now let's look at here. Is that current is the current bitwise n of the incoming left side parameter subarrays, I guess, right? So this is the idea, right? And the idea here is, this is use this number and keep going. And then this other thing is use this number, but n on this current index, right? So that's basically the 2 things that you have to do. It's kind of almost like a tick no tick kind of, right? This is an n no n, so this is ending it, and we could only end it if it's equal to n value, if it's equal to this n values, right? And we can also keep going and not use the used. And not gonna go over it in that much detail, but even though that's not the interesting part, right? I set infinity to all 1 so that the bitwise n will allow us to get better. I'm not gonna go over the bitwise n for this problem. This is a very hard problem. This is an 8-point problem, so the stuff that I'm not going over, and I don't mean to be mean, because this video, even without me explaining these things, it's gonna be very long. Not 3 hours long, but still pretty long if you want to understand some core concepts. But so I hope I'm not being too mean by saying that you have to understand bitwise ends and some properties about it, right? And yeah, and there are a lot of bitwise end problems on Leetcode that you can practice on. But this is just the complexity, right? And then the question is, okay, well, index can go from 0 to n. We already wrote that. Used can go from 0 to m. This can go from, well, what can it go from, right? In theory, well, current, what is current? Current is a number that is bounded by nums, and it can only go from 10 to the 5th, and 10 to the 5th is what? To the 16? To the 17? To the 17, right? That means that there are 2 to the 17 number of bits, there's 17 bits with 2 to the 17 number of possibilities, which is 10 to the 5th, roughly, right? Well, how can this be fast enough, right? Because if this is just O of n times m times 2 to the 17, or 2 to the number of bits, right? Well, this is going to be too slow. But the question is it, right? We call that current requires, or it's a result of a subarray, right? And this kind of took me a little bit to convince myself when I was reading this afterwards, but it is a part of a subarray. And what does that mean? That means that, okay, let's say num sub I is all 1s, right? And this is actually bigger than the possible numbers, but let's say we have 17 1s. I didn't count it, so let's say that, right? And then now, let's say we're working on it backwards, right? Well, what does that mean? That means that, okay, let's say, for example, let's say index is 1,000, right? It could be 1,000, right? So index is 1,000. Current is this number, which is not even possible, but it's like 17.1, say, right? Well, now, how does index 99 or 999 can possibly change this, right? Let's say you have a subarray from 999 to 1,000, and you have a bitwise n on those operations. Well, what can possibly change? The thing is that well, one case it can change, it could just not change. It's just the same number, for example. But maybe another case is that it is missing one, so that the bitwise AND would maybe I wrote this a little bit awkward actually. Let's say here nums is equal to this number and 0. So then now when you have this course to 1000, now current, the new current, another possible input is going to be just this with one fewer 0, right? Okay, right? Yeah. So then now, what is another thing? Okay, let's say it's 998, index 998, nums is equal to whatever, I don't know. Let's say there's another 0 here, right? Then now it's just something like this, right? Or it could be even with a 1, it doesn't matter because this nums goes away. But then now by the time it gets to index is equal to 1000, current is going to be, well, like and then that's it, right? So here I hope that it comes out with the pattern, which is that you can only remove well, I guess the fewest you can remove is just no ones, but 0 ones, but that's the same number, so you reuse that, right? But it also means that every time you come here, all 2 to the 17 possibility is not possible. You can only remove 1 0 or 1 1, sorry, and and replace it with a 0 every index you go back. And it doesn't even have to, right? Like for example, if this is just another 1, then now nothing changed when it comes here. When it comes to here, then current is going to be this thing which you've always seen, so it gets memorized, right? But the point is that, okay, so because every index that you go back can only remove 1 1, there are only 17 possible inputs to this, right? Because another way of looking at it, yeah, right, is that you only, and just to be clear, you can't go more than 17 indexes back, but you can only remove 17 ones one at a time. And that ordering is deterministic, right? And what I mean by that is that ordering, make it a little bit bigger, that ordering, like in this case, if this is the input, there's no way to make this 0 and this last element 1, right? Because the element before that, because this is a sub-array, not a subsequence, there's no way that this can be 0 and this could be a 1 if you want to have this be 0. So in that way, it's like when you do a binary search of monotonic function. In this way, this is kind of like a monotonically decreasing function going backwards as a proof, right? To bring that number forward to the current index. And because of that monotonically decreasing function, remember, if you are already currently an index, the biggest number that it can be is, well, the number of nums of index, right? Because if you have all ones coming in, after nums of index, it is only going to be current and nums of index, the bitwise and that means that you're bounded by nums of index. And then you have this over time, right? So that means that even though you can go further back on the indexes, right? Because remember, like for example, you can just have, 111s. Like you could have, and I'm doing binary here, right? And then and now we're at this number, right? So all these, maybe you have 1011, right? So this can go back very much to delete 10 when it gets to here, but it still doesn't change the fact that there's only 4 ones to delete. So it's not, so you can't just do a previous index, but you can do this on the bitwise. So that's the tricky part. That's the hard part about this problem, is recognizing this property and proving it. Or I guess maybe you could also just YOLO, I suppose. I don't know, right? And that's it. That's the complexity of this one. Okay. So this is, I think, the intended solution. Like I said, it's very beautiful. I've done I've solved a similar thing before, but I think for this one, but yeah, I think the reason why I solved it last time I did something similar and not this time is because last time I did not try to use a segment tree or sparse array or sparse table or anything, and this is where we'll get to this is another solution that you might have seen, and we'll get to that now. I just want to narrow down this part. So pause if you don't understand it and leave a comment if this part struggles or you struggle with this part, right? So okay, so this part, the second solution, the one that I eventually got in 3 hours, though I actually like the idea I got very quickly and actually was correct eventually because I proved it after 3 hours, but I just had a lot of implementation issues with segment tree. But okay, so the idea here is to reduce this this dynamic programming, right? Problem, right? And the way that the way that I would think about this is just to figure out how this gets used. How you fill out this table, right? So, so I'm bringing up the drawing real quick. Yeah. Sorry, that was from the previous file. I just had to delete it. But yeah, but basically, if you think about the if I look at my code, which I showed earlier, and then you kind of look at the dynamic programming table, right? So you have, some table. And then it's just about figuring out how to fill or how this table gets filled, and then figure out another way to optimize for this, right? So then now the thing with this table, and maybe I don't need to draw it like this, I don't know, is that because it's I'm not showing the code at the same time, right? Yeah, but basically you could say that, for example, we start off at 0, 0, so we start off at here, and here, let me change the color real quick, will depend on the bitwise end, but let's just say that this thing depends on the values of the minimum of this, and this, right? And then now this reaches out and depends on the value of this, and maybe this depends on values of this, and well, it actually can go upside. So it depends on this, and maybe this, and so forth, right? So you have all these arrows. And the thing with this particular thing, let me show the code real quick. The thing with this particular thing is that here we're trying to minimize this function, right? We have two, and you can see that this is minimized over a range. So what does that tell me? What that tells me is that, okay, here, another way to think about it is that we're minimizing for this original x, we're minimizing this, right? So that means that and we cannot do the actual for loop because it's too expensive, so we are able to fill this out in a way such that we're able to fill this out in a way such that we go backwards, for example, like bottoms up. If we're able to fill this out, and then now all we need is a data structure, a range minimum query data structure, right? Like an RMQ data structure. And with that, that's basically the idea. And the two ways there's probably more, but there are two ways that are off my head that could do it, right? Which is segment tree and sparse table, right? And the idea is that we fill out this table backwards. I can't erase enough, so undo doesn't work. So let's say, so then now basically we do the order of, okay, we fill this out first, and then we fill this out, we fill this out, fill this out, fill this out, fill this out, fill this out. So then now by the time I'm on the second row, right? Well, maybe not here, but now we're here, we can just look up the best previously and so forth, right? So then here we can look up the this range maybe, and then here, right? So okay, so that part hopefully makes sense, right? That's one part of the problem. It is not enough, right? Because then the question is, I mean, so okay, so let's say you have the ranges. If you have the ranges, then it's easy because it's a min query, right? But then the question is, let's say you have this x. How do you to find this range? You still need to get a loop, right? Because let's say this is your range. How do you find this? How do you find this point and this point? Well, one way to do it is through a loop. But if you have to do a loop, then in theory you can have crazy, like degenerate cases where you have to loop through the entire thing. Like basically, for example, if all the numbers are the same, which is a very basic one, right? Then now you have to loop through everything, and we loop through everything, then you have the same problem all of n. So here now you need another data structure. You need another data structure for basically for getting this for the bitwise n. And with that, you need a data structure to get. Now, okay. I'm going to pause a second here, and hopefully this makes sense, right? So this is the way that we're filling out the table. And this is the way that we're filling the table, basically from... why it's not deleting? Okay. From... sorry, showing the code real quick. From this formula, right? Basically, we're doing the minimum part. But it doesn't, so the minimum part is basically like this part where it mins over this range, right? But we still have to find the indexes to where this is true. And this is where we use binary search. And with a binary search, the thing with bitwise n is that it is monotonically increasing, right? Or, sorry, decreasing, because the more numbers that you add to a bitwise n, the smaller number that you get, right? So then basically the idea here is that, okay, so let's say you have a range, right? So then now, let's say you have at this number, then now you could binary search for the first instance, right? Where this is exactly n values. And binary search for the last instance where this is the same thing, right? And once you do that, then now you have the range. And the thing that you have to do is figure out that, for here, the bigger part, this is going to be greater than n value. And for this part, because it has too many values, this is going to be less than n values, right? And so you just have to do this binary search this way. Conceptually, this is fine, right? And the way you would do this is also with a segment tree or sparse table. Like I said, I'm not going to go over sparse table or segment tree for this particular problem because it would take me forever. I mean, I barely solved it, right, in implementation. I mean, it's not that bad in concept. There's just a lot of things you have to do. But yeah, that's basically the idea that I had. There are some nuances with this. The way that I did it with segment tree. I did 2 segment tree. One is the n segment tree, where you can see the bitwise n here. And basically, I'm not going to go over it in detail, but basically, it lets me query for a region. For a region, give me the bitwise n of that region. That's all you need to know. You can think of it as a black box. And then I have this crazy, I call it segment tree 2, which is the one with the minimum one, right? Like I said, you could do it with sparse table. I'll show you an example of that. Josh did it that way. I'm gonna steal his code, but yeah, because I'm not doing anything by writing it. But yeah, but this is the rest of the code, right? So basically, yeah, the way that I did it is that I fill out this this table like in a dynamic programming way, going backwards, like, from the corner, upper right corner. This is why I go backwards. I calculate this. And the way that I did it is actually slightly different from what I said, because basically the cost is the last item. So you have to kind of go backwards a little bit of, okay, if this is the last item, because the way that I have it on this dynamic program is starting an index, but the way that I actually changed it to make it the min query make more sense is that we end at, so you can kind of think of it just like reversing, except for that now, maybe I should have just reversed array. Maybe that would have been easier. But basically, we add end of index num sub index, so then we could get the cost of this much more quicker. What is the best cost, right? I mean, that's pretty much it. It's just that we end at this index instead of we begin at this index. That's the nuance, because then now the best score is just going to be used +1. We query for the next thing that because basically now in this tree we store, so this function is we end at here. What is the best cost of let me rewrite this. We end at num sub index, we update the best scores that ends here, right? And the reason why that's a distinction is a little bit tricky, but basically now you're able to get the best score by just looking, we end here, so we have to do the num sub index as a cost, and then we query, because the queries, so we update the best scores so that the tree still has the thing where it begins at index, right? So now we begin at index +1 or after used +1 tree, on the used +1 tree, and that's where we do it. And here I have a lot of debugging code, but here we have the two binary search, right? We have a binary search to get the left range, and we make sure that this is equal to right, because if the left range doesn't equal to use, then it doesn't exist. But if it does exist, then we do a second binary search for the right range, and then after that we do a range update on the good left and the good right, so that it updates a chunk at the same time, because all of them has the same value, right? And that's pretty much it. And I set the base case of at m, we set the value of n to 0. So that's pretty much it. And at the very end, we go, okay, if we are able to end, is this right? I mean, this got accepted, so I don't know. But yeah, and that's pretty much it. Maybe I have a typo. So if I have a typo, good luck. But that's basically the idea, is that I do these updates and so forth. And I would say on Leetcode, there's actually time limits on Python. I had to use ChatGPT to convert it to C++ to get it accepted, and it works. So I am validated in that sense. I don't know. Am I happy? Not really. Took 3 hours on this. But that's basically the idea about this. The thing is that everything I said is still true with the sparse table version. So I'm just gonna go over Josh's code real quick. I just want this to be a little bit bigger. That's fine. I mean, it's not quite, whatever. Okay, fine. Right. So this is Josh's code, but this is the same idea, right? So first we set the DP. We have a sparse table, and he does the space optimization thing to only look at the last two. But there's also a practical reason on it, because he uses a second sparse table. And you need two sparse table, one for the bitwise n and the other one for the min. This one seems like it's the min, and the other one is the bitwise n. So and basically he fills it up backwards, like we said. Set up the sets up the base case. Sorry, my allergies is kicking in because it's so late. And then here, oh yeah. I mean, basically, it just adds the value, right? To set the cost, and then I mean, all these loops. So this loop and this loop is pretty straightforward. It is what we said. It binary searches for the boundaries and then gets the query. So he does it the more straightforward way of querying the last thing, because he is able to add the way that he did it. He is able to add this DP much more straightforward. Maybe I could have still done it that way. I don't know. But yeah. But he has the cost, so that DP sub I now contain basically just throwing the table that we set, right? And after a row is done, he converts it to a sparse table so that he's able to answer min queries. Much cleaner than the way I did it. But yeah, and then here is just binary search, which is what we talked about to get the left and the right. And that's pretty much it. And yeah, and just, return -1. But yeah, obviously, Josh being Josh, the code is much tighter and faster, and he actually solved it, for example, right? Did he do well? Fifth, pretty good, I think. I don't know if he actually... Well, I mean, it's good. I don't know if it's good for him. He gained a little bit of rating points, so congrats, Josh. But yeah, that's basically it. I don't really... So it's same ideas what I had with the segment tree, right? So all the visualization apply, everything's the same. It's just that he uses a different data structure. Yeah, and I really, just to kind of also recap a little bit, the way that I did my segment tree was, like, I spent honestly an hour because I just forgot about how to code the queries, and I had an off by one somewhere in a couple places and a lot of wrong answers as a result. Like, the idea, I actually got it within the contest, I just couldn't code it. It happens. I don't know if I could. I did thought about sparse table, but one thing that I miss about sparse table is that you cannot dynamically update to get the min. But I also just didn't think about this case where the kind of like the space optimization case of just doing it after you get the entire row, which is very smart. But I just didn't think about it that way. Yeah, I mean because then now, not you don't need any updates in the way that this is done, which is way cleaner, of course. And the complexity is also a little. No, I mean, I think because the complexity is also better because the query is all of one. Yeah, query is all of one in a sparse table, right? So this is actually a tighter log n, where on here. The way that I did it, this is log n, and we do a log n loop, so this is going to be log square n, right? Which is why it times out, at least in Python. It works in C++. But yeah, that's all I have for this one. Let me know what you think. Let me know if, I didn't go over sparse table or segment tree. Let me just write it out real quick. If you want to Google these things, you could spend a couple of days just learning seg trees. Or segment trees and sparse table, right? But I don't know. Do you need them? I don't know. But that's all I have for this one. Let me know what you think. And yeah, the next part of the video is 3 hours long, so enjoy it. Thanks for watching. Stay good. And yeah, you can watch me solve it live during the contest. Now and after the contest, really. Okay. Give it a submit. Okay. Whew, how many people got that one? 31. Yeah, I mean, I should have gotten that one earlier, but this is painful, the one wrong answer, because otherwise I think I'm pretty good. Now we'll see. This is now an 8-pointer, so it's not even going to be easy. 30 people submitted already, so, I mean, unsuccessfully, so we'll have to see. Alright, read the problem though. Nums and value of n and m. Last element of that array. You have to divide nums into disjoint contiguous arrays so that the bitwise end of the subarray is equal. Okay, so then now we have to do okay, and m is big. What does this mean? What's NYU? Oh, NYU is just at most 10 partitions. So minimum possible sums of the values. Okay. No one's gotten it. It's not just DP. Actually, I mean, I guess maybe it could be like. I mean, I guess if you're sloppy, it's gonna be n whatever. But are we trying to minimize? Okay, so I mean, it's probably still DP, but we have to figure out what the DP thing is. But I feel like I had a thing with binary search. Is that right? Is it a seg tree as a result? DP with seg tree, binary search makes sense, kind of. That 10-minute, 5-minute thing would have been actually feel pretty fast, faster than I expected. Still, one field got it already. I mean, I think it is. Is it? I think it is seg tree, but what is n is 10 to the 4th, so it is seg tree or both. Seg tree binary search. You have 2 bounds. I'm trying to not do seg tree, that's why. But the value, right? They're most 10 things. Man, I'm a little bit salty. That is a stupid wrong answer. And I spent a long time in Q3. And it's 10. Okay, if I write the naive dynamic programming, what does that look like? It just looks like 2 for loops. So how do I do that in a smarter way? I don't. I mean, this is not correct, but I have to write it so that maybe I could see an answer. Minimum. What is there now? It's just so then now. That's not true. I don't know why I use X. Yeah, whatever. I mean, there was some early termination, but right. In this infinity case, but that's fine. Okay, fine. I know this is all. Oh, I forgot to actually add the thing. Alright, so this is right, but obviously it's too slow, right? Because it's n squared. Can I optimize this? This is just getting the min of a range. That range can be binary searched, maybe? How do you binary search the n? How do you pre-process the binary search again? I don't even know. I mean, it is sig tree, I think. I just have to see if I can find my template for sig tree. This is so silly. I hate sig tree, as you know. So I kind of fought against it for so long, but I don't know another way of doing it. Of course, you use sparse table, can I? No, you need it for you need a sig tree and a sparse table, maybe. Don't I have a sig tree? Oh, this is a max sig tree. Okay, fine. I mean, let's just do it, Larry. You hate it, but you have to do it. Here's my sig tree. This is a max sig tree, so I have to make some adjustments. I don't know why I wrote it this way. I guess that's really it, to be honest, for that part. And then now, is this the one with lazy propagation? I actually don't remember. I need to write one with lazy propagation, but this is n anyway, but that's fine. Let's see if this actually runs. Yeah. What is M? Oh, the initial character, that's a... I wonder if this is right. Okay, and then now we want, yeah. I always forget how to use this thing, to be honest. Why don't I have usage? I always forget this is like a 1 or something. Okay, let's say now we have a range. I'm gonna get the min of that range. It's not even that though, it's the min of this range plus this value. So that means that each of these should have the value itself. Okay, fine. Okay, fine. Let's just do it and see if this works at least, right? I want to save this code somewhere so that I have at least something to compare it against. And then now, yeah. Okay. Physical index. I forget. There was a way to do it up there, but I don't know how to do it off my head, and I don't want to spend time on it. I think this is roughly right though, but we have to get the first. Let's see if the naming is wrong, but that's fine. Is this right even? I want to make sure. I feel like this is roughly right, but I always forget how to do it. Don't know why I don't have a better thing for it. If this is equal to or greater than, then okay, then that means that left is good. Right. Then if then this is the first side, right? Then left is the first side. Fine. So we would have 10 used secretaries. That is a lot of memory. Oh, a lot of people have it. Good for them. Okay, I mean, just look at it, Larry. Come on. So if this is good, then we want to also find the right side, right? So good. This is so yucky though, but it is what it is. Grind it out. If it's good, if it's not, we probably don't have an answer anyway. So, we thought about it for so long. If this is, now we want the last one, right? So, if it's greater than or equal to, then it's still good. Is this right? No, if this is greater than or equal to, that means, okay. If it is less than, then right is equal to mid. Okay, right. Equals right. Okay, and then now we'll just write something like just for science, we should be able to convert this to okay, so this should at least give us the same answer. Except for its memory limited exceeded. Why? Is it here? Am I querying it wrong? Oh, wait. That's because this pass is not initialized, I think. Maybe. Hopefully that's it. I don't know. Wouldn't they just return none or something? I don't know. No, still not an issue. What is wrong with this? Alright, that's good. So that means that it is with something here. Okay. Did I call it wrong? Max left right. Index mid sounds right. Right? How could this run out of memory? Yeah, okay. Okay, so it clearly runs out of memory because it's infinite recursion. That's what I thought. N-1. I always forget the default values. I guess that's why. Okay. It's still a limited thing though, so that's not enough. Well, maybe it's, no, it's just this part, right? Guess this should be N-1. I don't know. That's why I'm not storing enough. Okay, it's still going infinity because it is 5454. Why is it not turning? 5454 we return, right? I can't debug this and do it at the same time. No, 54 we just return 0. I'm too tired to debug this because this should have been elementary. Like I don't even know how to use my code because it's been so long. I need to practice this one. But okay, why there's no places give how to call this thing. I just forget what the default value should be. One and all. This seems right. Am I wrong? Is it this? I don't think so. Usually it's not. I hate my life right now. Just because it's not even that I'm debugging the code yet. I'm debugging like how to use this. That's annoying. Why is okay. Some people used segment tree on the earlier contest, so I'm gonna see how they use it. I'm just really bad today. Of course, now that I'm looking for it, I can find people using a segment tree. Oh, there we go. Build tree is crazy. Yeah, that seems like what I'm doing. Here, right? Why is it wrong? Is it N? Am I confused? Well, okay, maybe I was confused, but why? Why is N minus 1 wrong? I think I built this wrong. Okay, let's see. Oh, this is also wrong because I didn't fix this, but that's fine. Easy fix. Alright. Come on, Larry, just fix it in all the places right now. Okay, I mean, that's good. I mean, at least I am such a dumb. I need to update my notes though. Okay, does that help? Good left, good right. Good right is wrong. This should be left, but I mean, it doesn't really matter a bit. But okay. Why is that? Okay, mid is if this y is greater than it, otherwise left is gonna feels right. I mean, this is exactly the same as before, right? Like, am I doing something wrong? Oh, maybe I'm putting too much now that it actually does stuff. But that means something else is weird though. Oh, no, it's just because I forgot this +1. But should still terminate. Right? That's actually not great. Maybe it's the printing. Why? Is it just that I'm using too much whatever? Okay, so no for loop is good. Does one level recursion okay? That's not great. So I can't even get this right even if I am able to fix this, which is definitely not good. Why? How? Isn't n small? 10 to the 4. This is only 10, right? How is this infinite space? I mean, how does it use that much memory? Also, I only have 5 things. I'm not even. I'm not even using the big numbers yet. Is it one of these? Index, mid, something like this? This one? Is this n minus 1? Is that right? It appears of this thing though, right? Yeah, seems like there is a thing here because I don't know how to use index trig. I don't know how this happened. Like, what is going on here? And this is returning 0, right? Like, why is that an issue? Is it because, oh, wait, no, I, right? I's always 1, so where is this getting it from? 0, 4, 0, 5, 345, 3D. Right. So it's doing these things, I guess. And it kills me. Because I know I'm just setting it wrong. It's not even like I'm messing anything up yet. I just don't know how to do it. Because I forgot it and I can't seem to remember it. I don't know why. Yeah. Trying to find a sec tree example. Because I'm clearly not calling sec tree correctly. I hate my life. Because I'm not even debugging the code yet. I know how to solve this, but I am just doing dumb things because I have not practiced enough secretary, and now I can't even find my Leetcode window. Oh, there it is. Wait, some of them. Yeah, I guess that's what happens when you don't practice enough. But I don't know, it seems like that 1, 0. Why is this not right? Okay, what is going out of control here? 4, 4, 4, 5, which leads to this and this. But why is this less than? Why does this keep going? Do I have TM? Right? Why is this so weird? Alright, maybe it's just this, but I have to fix it later. See if that fixes. Still. Still 5 4 5 4 5 5 5 4 5 4 5 5. So why? This is not true. Oh, I did it the other way. But 5 5 5 is over 5. 5 is over 4. What? Oh, that's fine. Wait, what? Oh, that means that this actually fixed it. Okay, fine. Good left, good right. Okay. Right is. That's awkward because how can good left and good right be different? Exactly the same thing. This is the same code. Am I doing it wrong? Oh, I have n-1. Okay, fine. Alright, so that seems wrong though. It's not, shouldn't be 4. Good left is 4. 0 1 2 3 4. Let's take a look to see if this is right. I'm just debugging my, whatever is so dumb. So I'm not even, and this is clearly wrong. So I don't even know how to do this because I'm doing it dumbly. Doing it in a dumb way. Or like I apparently do not know how to do this. But let's at least get one thing right. Why is this so wrong? Am I doing that part wrong? I think I'm just doing everything wrong because everything is returning 0 for this reason. So it's fixed, but not really. Alright, apparently, maybe my code is terrible, but I'll see. I'll use chat GPTs. Is that even better than my code? I don't know. I'm wasting so much time on this, which is the sad part. There's no update. Okay. Oh, because I'm doing it the way. Actually, that's even better, maybe. Okay. And now I have st dot. Alright, let's see if this works. Maybe it does, maybe it doesn't. No max. Yep, that's true, because now it's an actual query. Yeah, and I spend like most of my time debugging max. So, okay. So that doesn't seem like it helps. Oh no, that's because, but still, it doesn't really feel like that changes anything. Oh, actually, maybe it does. Now it's index I. Does that help? 0, 1. Oh, this should be right, actually. So, okay, fine. Right. So maybe I should just ask ChatGPT next time for sec3. Okay, so then now we want, but this is still not 4 though. Why is this returning 4 for left, good left? So this is greater than or equal, oh, greater than or equal to, then it makes, okay, if it's greater than, then, oh, it's the other one, actually. Still have half an hour, I could fix this, but still, maybe. Oh, whoops. Waiting so long for it to give me a time limit exceeded. Okay. Okay, 2 and then now 1, but that's true. So then now it goes 0, 2, which is great. Now we want to be worse, so we want this to be here for the good right, and then the left we want it to be, well, in this case it's still 1, right? Oh my god. So far behind. It's not even, the annoying thing is that I'm not even debugging the code, I'm just debugging stupid things. Alright, let's just debug one at a time. I'm changing too much code. What are you writing, Larry? That's not right. Okay, so we want the first case, right? I'm just so bad at this. Okay, so if that number is bigger or equal to, then we set it to right. Right, otherwise it's left plus 1. Okay, fine. What am I doing? Okay, so 2, I guess that's right. So 2, right? But that's for this side. I think that's what I want this part to be. And then for this side though, is it still the same? No. Well, I forget if this is one indexed. I think this is one indexed. No, because I don't know why this would be 2. Not sleeping early today. And the idea is not even that hard, but so 0 is 0, 0, 1 is 1. Should it be 1 and whatever? No, I mean, index is 0. 0 and why is it 0 and 1 though? Oh, yeah, then it is off by 1. Right? I don't know the nuances of this enough, but okay, fine. Right? That's 1. So we don't want to do that. So 0, 2 is going to take 2 numbers. Okay, fine. But we also want. So, okay, so we want the first instant where this is true, and in this case we have left is equal to mid. Right? Let's just focus on this for now. Okay, so that oh no, good weight is not 4. So okay, so if it's bigger, that, or you could if it's bigger, so if it is bigger, then we want to go to this one. Okay, fine. Okay, 2244, I think that's coincidence, so that's good. I'm so bad at this code. Okay, fine. Okay, I think we are finally good. Right? Maybe. Alright, we still have 26 minutes. I could solve this, maybe. This should give the right answer though, so maybe not so much. What is my base case, right? Seems like it. So we go 0, 2. So then now we start with 3. 3 and 3 is 0 is probably wrong. I think the off by 1 indexing is a little bit weird. I'm not familiar enough with it. I think that's where I'm getting stung. Because the 3, 3 doesn't make sense. That's why it's not returning anything. So we want this to go to 0, 2. 2, 2, so then now 2, 2 is actually this minus 1 for some reason. Fine. Okay, so then now we're 2 to 2. 2 being 4 is really bad. Now we want 3. 3, 3 is, why is 3, 3, 0? Maybe this is just wrong. Why is 3, 3, 0? Oh, it doesn't include itself. So what does that mean? Well, 3, 3 is 3, so it does. So it doesn't go here, but why is 3, 3, 0? What's 3, 4? Oh, why is right? This is n. 3, 4 is also 0? Why? If this turns out to be a thing from sec tree being wrong, that'll be funny. I just don't have a good effing sec tree. Like, why is this 3, 3, 0? This is just wrong too. Because how can it cannot go to 0? Is this right? I mean, it looks right-ish. But it's definitely not right. This is just... That's why I'm having issues, is because my code is not right. Wah. Crazy. Oh, wait. They tell me to use it with 0 on this one. So maybe I'm just being dumb. Is that true? Oh my. That is pretty dumb. Okay, so 2, 2 is 3. Okay, so 1. Two, 3 should not be 0 though, so this is still wrong. Wait, maybe I'm just doing some other things wrong. Oh yeah, like n minus 1. This is what happens when you have different sec tree implementations, and then you just get confused over it. Alright, 20 minutes, I still... Okay, I mean, we got this one wrong, but maybe that's just like an off by 1 somewhere. Okay. Okay. How do I get 19 wrong though? Oh, 19 is... okay, but I mean, that's fine maybe. Okay. I can't believe I'm just a dumb. I mean, I could believe it, but it's still not great. Just want to make sure that this is right. Because I don't know, if I haven't gotten this 19, I would have been very curious, to be honest. But... yeah, okay, fine. Okay, so for the second problem, I don't know if I have enough time for this. I am being too dumb. Okay, focus. Okay, 6, 6. 6, 6 is 5. Okay, so 0, 1, 2, 3, 4, 5, 6. Okay, that's true. 5, 5 is 7, so it's 12. Okay, and then 0, 2 to 4 is 19. 0, 2. Oh, that were no. 2. Why? Four is 19. Okay, so yeah, but what is 2? It doesn't do it. What is the good left, good right? Why doesn't it loop through the thing? Huh? So 419. But why? Why isn't good left good right? Am I being fake here? Huh? This is a for loop, right? Am I not writing a for loop right? 0, 2, 4, x. Did I update x in something? X is a terrible name, I guess. Yeah, okay, fine. I just want to solve it. I don't even know. I'm just so confused. Why? 4, 5, 6. Oh, because it's recursed out, but oh, okay. So 0, 2, 4, 2 is infinity. Maybe that's true. Is that true? No, that shouldn't be. I just don't know how to read. 3, 3, 3 is infinity. 4, 6, 4. Fudge. I'm so close, but I think I'm having it off by 1 somewhere or something. Because it's the used part, I think. But if I didn't spend so much time on that part. So there's 4 parts. There are 3 things, and that's why, I suppose. Oh, I guess I forgot that actually. I mean, it's still, but oh, the 3. What is it? Okay, I see why now, but 3, 7, 7 should be 3, 3. So the good left and the good right is not right here. This should be. How did I get the last one? Why am I so bad at binary search? Okay, so that means that if it's Leetcode, you want to keep going. Yeah, right. Okay, and then this is this minus 1. Okay, we know it exists, so. Alright, maybe not. Okay, so I am just dumb, but okay. Alright, still too slow, but now we can do something about it. Where's my ARM-Q code? I'll just ask ChatGPT again. Or just another sig tree, right? Or like n of them? A regular sig tree? Where's my... And you give me a minimum sig tree in Python with updates. Oh my, there's so much code. Example usage is actually helpful, but nonetheless. Okay, we have to figure out how to do all these other parts bit. Okay. Yeah, if it runs out of memory, that'll be funny too. Now, times n, right? Yeah. See if that does anything. Then I put segment tree too. Alright, at 14 minutes I could do this, right? This will time out, so then now we have to update. Right, so then now, how do I update this? STM of used dot update. How do I use the update? I forgot. Update range update. No, just update one thing. Okay. 0 0 n-1 index and the value. Index is index and the value is best. Okay. And then here we want to say used.query, right? n-1 the minimum between good left and good right, right? But is this plus num sub index? That's the big thing to update it. Right? Still 12 minutes. This should be wrong because I don't do this in the right order. So the how would I get this quite precisely right? Because I don't do the thing enough. Because this thing is not giving us the base case. Of how would I set up the base case? Oh, this is used +1. So maybe that's how. Okay, okay. That's fine, because I think I just need 2 times this plus 1. It's good left, good right. And it's used plus 1. Okay, so used plus 1, and then it's I plus 1. So is this really right? Maybe it's this. Yeah, I don't do the base case. So 4, 4, 4, index 4. Is this plus 1 maybe? I spent too much time on this max tree. Come on, Larry, you can't do this, kind of, maybe. So close. Four, 4. Okay, I mean, maybe that's some of these has to be right? If used is equal to m minus 1, and good right is only goes to n minus 1, right? So I don't know. Still not enough to update. Oh, because that's why. Because I'm being dumb. Let's see. Right here is what I need. And yeah, okay, fine. Does this give me anything? No. Poop. I mean, I don't know what to say. This gives us not the right answer anymore, actually. Why is that? Oh, because of this thing. This is going to time out, but I'm just going to submit it for the record. Oh, not even the right answer. So maybe I am just very wrong anyway. I think it's this thing though. No. Okay, then maybe I'm. I spent too long on Q4 on sec tree. Why is this wrong? Maybe I should have done that. It's either that or I'm just missing some really obvious case. A lot of people got it. I didn't get it. I thought it was DP. This is what happens. So basically I have like 5 minutes till the end of the contest. So this is going to be terrible. A lot of people got it. So maybe it's not this crazy thing that I'm doing. Because what I'm doing is pretty hard. Or maybe it is. And they just didn't spend half an hour on the secretary part. Which I still need to fix. I feel like this is... I mean, I can get it to be right. But I feel like this is still maybe right. Maybe I'm just having some issues on this one. Why is this 15? 15 is yeah, I think this, so it's gonna be 4 plus 5 plus 3, right? So why do I 15? Now I'm curious, to be honest. Two to 6, okay. I mean, yeah, 2 to 6 seems right. That we can go to 2 from. No, 2 is not right. Though that would give us a better answer anyway, but that is wild, actually. I mean, is it because I have this thing? I don't know. No, it still gives me the wrong answer, but well, I mean, I guess I was wrong anyway. Maybe they're just having a rough day. I was way too tired. Index use left to right. From 0 to 2. 3. It goes to, so from 2, I guess it goes to 3. 3 is no bueno, 4 is no bueno, and then 5 or 6. Well, 6 is with 2, 5 is with 4. So then why do I have, oh, because it's this, and, but 4 also works, right? Why don't I go 4? So 3, 1, 5, and 7 should be right? I am too much of a dumb today. So we'll try to upsolve it by taking a hint. But this is kind of disappointing. So for this, what was it? 1. Okay. From 3 is going to be 4, I guess. But where's the 2s? Why doesn't it go to 1, 3, 2 is not 0? So okay, so then now we have 4, right? So then we have 3. 3, 4 is 4. That's not right. Right? 3 and 4 is... actually 3 and 4 is 4. But we actually want 4, so 0 to 4 is 0, that's good. And then 4 to 5, I guess my binary search is wrong because my, oh, why is my binary search wrong? I don't have binary search apparently. Yeah, I don't think that was to fix. Because basically with Leetcode, then we get to the last one. This should be Why is this good way to let me double check this print. I'm like debugging 8 things, but I'm just annoyed that this doesn't. Why is this 4? 4 is 7. So it's greater than, so it should go to that. I can't binary search apparently. But like 4, 5. It should just give me 5 or 6. And this is why this is wrong, but still don't know why though. Because we print out all the queries, so it's not like. Oh, what the? I have a 1 here. Alright, well, that is a stupid bug again. Alright, let's. I mean, like I said, I think this will time out, but I just wanted to get at least like I don't know how to use sec tree clearly. Though if it ACs, that'll be amazing, but it shouldn't be because it should time out. But maybe this fix. No, I don't know how to fix this thing though. So yeah, I don't know how. Like it should be that I'm able to replace this with. Okay, so there's another wrong answer somehow. Output is 4. The answer is 7, which I agree with. Though I don't know how this is. Why am I so bad at sec tree? Expected answer. Yeah, I mean, did I do anything wrong? Yeah, I mean, that was just a silly mistake from, I don't know how to code all the other ones though. Just give me. I just want to get a time limit exceeded, and then we'll try to upsolve. I don't want to look at it quite yet. Okay, so then now why is this wrong? So you have 006, which is accurate, right? So for 0, we have 0 to 1. Oh yeah, because this now pushes you to the right. So then this should be this. Okay, yeah. I mean, I knew that was the case, but okay. Wait, what? Why is that? This. Now it's going to give me all -1s. Why? But that is wrong though. Why is this going left right of 0 to 1? 1 is 2. Oh no, that's right. But why is that when I fix this? Because this should give me the biggest index that is, or the first index that's not. Oh, because of this thing. Okay. Okay. So I knew about actually I knew that I did this binary search a little bit. Like I knew that this was wrong, but I couldn't figure out why. Or like there are other things that are wrong that mess with it. So I was just like confused. All right. Let's again see if we get a proper time limit exceeded. Just debugging very basic code. That's like the sad part, right? Like I'm okay with getting a time limit exceeded, but like I knew that was the case, but getting a wrong answer is kind of a little bit very sad. This is going to time limit exceeded, so we can maybe stick, because I'm trying to figure out how to. Yeah, I expected that's the case. I'm trying to basically should be able to you know, write it this way, but I don't know how to do it. It's a little bit off, I guess. Is this right? No, I mean, it should be +1 is fine. Okay. But I'm just being dumb on the sec tree. This should be fast enough at least. Okay, it is fast enough, it's just not right. That's fair. Oh, no, this is fine. This is n, and this should be 0, right? But then now, why doesn't this get me an update? Because this is n-1, I guess? No, but, oh no, this is n, and then this is n-1, and then n+1 should be okay. This should reach it if possible. Let's try a very basic like thing. So yeah, why does this not work? I mean, today I'm learning, so bear with me. But okay, so why? Good left 0 0, right? Am I using the wrong tree? No. This looks okay, right? We want to say, oh, 0. No, I mean, okay. Let's print what's it? M dot query of 0 0 n-1 0 n. This should give me hopefully 0. Nope. Don't I update this here? Do I not code this at all? Is that why? Oh jeez. Index is n. N, Larry. Yes, thank you. Okay, so this works now with this and this. Well, this works. But then now, why are you not calling m? M is 1, okay. So use this 0, okay. And good left, good right is also 1. Okay, so here we try to see m. What is good left? Maybe n? Is n? Is this thing, but should this be 0? I don't even know. I think what I need is actually, no, I mean, this looks right, the way I set it up. Though I don't like that this is, I like this infinity instead, but it should still give us an infinity, but that's fine, right? Why? We just updated this to n is 0 0. And we have n+1 things there. Am I updating the wrong segment tree? That would be funny. We set this, why? I don't get it. Does this change things a little bit? I mean, no. Why is this? Do I not know how to write? Oh, because of this n-1, I think. I am a dum-dum. I am a dum-dum. I have so many bugs on this because I just don't have a good understanding of, I mean I do, but I just been lazy about it. Or I think I just, or not practiced enough, I suppose. Okay, there we go. I am no longer too dumb, I'm just regularly dumb. And then here is the other thing, and then, Okay, so the left right is no longer working. Oh, because this one is this different from this one. Okay, that's why, which is also mad confusing. Okay, back to Nick, because they're different size. That's why, but it's still sad. Okay, okay. Okay, well. Oh, this is the best thing, right? But we updated for this, right? So best is going to be that plus the last value you used, right? So that's not a good base case, because it assumes that that contains the last value. Okay, that's fine. And then now it assumes this, which is also fine, but then the 0, 0 is wrong, right? So the 0, 0, 0 was best. Maybe I could just do this. I don't know, because I don't use it anywhere else. I think maybe I just messed it up by converting. Maybe it's still too slow though. Who knows? Yeah, it's still, well, it definitely is too slow when you print out so much things. So let's at least take that out. And then after this, if it still times out, and it looks like it might, we'll upsolve it a little bit. Well, good news is it doesn't time out. Bad news is that it's just not right. Huh. Well, the cache thing doesn't do anything anymore, I think. So I don't need it per se. I don't think this one's any slower. But basically I'm just doing DP in a better way, but I don't know why that this is so awkward. And also why, like, this is not going to infinity or something. Like, why am I not at least returning -1? But basically the idea here is that I can do an update, right? But, well, let me make sure that my other case is right. So at least I didn't kind of change it, because that was my getting the base case right. Alright, so I'm not too dumb, just regularly dumb. Am I off by 1 or something? Basically, this is like a DP. And maybe I should skip this one. Where am I anyway? I mean, not that bad considering I was just really... I still don't want to give up yet, to be honest, at least on getting this right. After I get this right, I'll be happy if I, you know, just learning. Sometimes you have to learn and you have to grind. You haven't seen me grind in a while, but it is what it is. Why is this 1 though? Plus this, and we do that on the index. So this is the last value. Oh, I'm messing this up. So this is the last value we should not. Yeah, okay. I am messing this up. This is actually way easier than the way that I'm doing it with the index. So then now. Yeah. Okay, fine. So then now this is basically, okay, so then I could write this as, that's actually pretty dumb. I mean, like, I'm pretty dumb. I should definitely have done this before. And then now, this mix. way more sense, right? So then now, if this is the last index value, but then now this is wrong, but that's fine. Oh, or maybe that's why I was wrong to begin with, but now I think this is more accurate. This is still wrong, but I want to just run it real quick, just to make sure it doesn't crash anything weird. And then now, I don't know what that means. And then now, we can do something like right for I in range from I guess doesn't really matter. No, I guess we just return best as you well of 0 dot query of from 0 to n, right? I mean, the idea should be right. It may not give me the right answer because, you know, there are a lot of struggles here, but that's actually a little surprising. Why is that? Use the 0. We would have updated everything. Yeah, I mean, I think we did. Well, 0 is a pretty min, but maybe I update something else wrong. Alright. Maybe I needed this part actually. Really? Well, it's just a lot of infinities. It shouldn't print that much. I don't have. Is there that many 2's on this one? Oh, I guess so actually. Oops. Let's just get rid of you for a little bit. We know what the timeout case is anyway. Alright, well. So it's just a lot of things and then the 0. Why? Am I just looking at the wrong thing? Nope, they all look like this. How did this happen? Tell me why. I mean, they're just all infinities in different infinities. How many infinities do I have? Let's get rid of this one. It's just very confusing. All right. They're all infinity. Didn't I have some stuff good that was good before? So M, right? Used 4, 3. Alright, that's fine. That's not a possible one. But this should at least give me something. Right? I guess I didn't need this, but do I not update anything? Why is this like so weird? No, I mean the good and the left should be fine, right? All right, so we definitely go in here. index used. Why? I don't even remember what should be good anymore. So this is a 2, so this should be, I don't know, 4, 3, 4. I think my base case is wrong now because I changed the way that this is structured. So what this should be is that so index is the last. I think I messed up how I structured some of this. Okay, so the index is the last item. Yeah, I think I have to fix some of this because if index is the last item, then we want to go left. Oh, that's what I needed to do. Yeah. Oh, that's a wow. Wow, that is that's all I needed to do. Okay. Yeah. Okay, fine. I mean, I have to do it. I have to do it. So then it goes from 0 to index, which includes index now, right? And then now we go from 0 to mid, 0 to left, 0 to mid. Do the are the directions right? Okay, so if it's, is it 0 to mid? No, it's from mid to index, left to index, left to index. This is an insight I didn't even have, so I mean, I think maybe I was way far off. Okay. And then if this something is bigger than the n, then we want to go so we want to go more, so left. So let me try this one first. Okay, so if now the n value is too big, to get it smaller you want to go to the left, which means that the right is, oh okay, maybe this is right. Okay, let's just run it real quick. I mean, okay, fine, I hate you too, but what am I printing anymore? I don't even know. Alright, the good left and good right are no longer, so okay, my binary search is definitely whacked. So let's try again. Oh, this has to be 0 to index as well. Just gonna run it real quick. Alright, I mean, I guess it just doesn't even go inside here because this loop is wrong. Okay, let's try again. So if it's less than or equal to, so if it's less than, then we want fewer numbers, so we go to the right. So that, okay, that's why. Okay, fine. And then now, if the number that we have is greater than, then we want more numbers, so we go to the right. Yeah. Maybe. I mean, I think this is right, but I think maybe I mixed up good left and good right now. Maybe. Oh, whoops. People got this very quickly. People are very good. I mean, and you could build this into the tree as well, I think, but maybe this is just an easier way. I don't know. I mean, I'm still trying to figure out this way just because I think I am able to do it. Left, right, yep. I think I got them mixed up, but that's fine. But then, yeah, good. Yeah, okay, well. Yeah, from 4 to 1, there should be, okay, so this is saying that the last number should be a 2. That shouldn't be go from 4 to 1, should it? Oh, I guess so, actually. Huh. Okay. Maybe that's fair. It's 4 2. Why is 4 2? Oh, 4 2 is. That's fair. 3 2 is 3 to 1, okay. But then now 4. Why is this one? Okay, 4 to 1. Why is that? Did I do it wrong? Okay, so it's giving me infinity. This should give me a 0. Right? 3, 4, Oh, because the n is no longer true. I have to do a +1, is that why still? To get the range? No, I mean... Well, this actually is pretty nice. Actually, this is what we want. I don't know about the other thing though. Oh, that's because I didn't do a +1 there. Okay. So then now 3 2 should give us this number, so I don't know why. Because we update the index, which is 4. We go 1 to 3, we go 2 to 4, okay, right? I had to do something like this. Also, 1 2 3. Oh, but it should be +1, right? So this is +2 technically. Two, three, four. Why? But we updated this, didn't we? Did I update it wrong? We update. Oh, I updated it. No, I mean this is right. I mean I flipped the thing, so it updated 1 4. We update the 4 to be 2. Right? Yeah. Four we updated the 3 to be 2. No. 3 we updated the 4 to be 2. So then why is this not right? Did I do this wrong? No. How? Head scratching. It's used plus no, it's use this 2, right? So 322. That should be explicit, I guess. Wait. Index used, so this is 4. Did I mess this up again? No, this is right, I think. This is weird. Just to sanity check myself that it gets updated. It is updated, right? What is going on? And it should be 4. I don't know, it doesn't really matter. Let's just try something big. So this is 0. Okay, well it's 0 because there's a 0 here, which we don't need anymore, I think. I think I just kind of... Okay, fine. Now all the answers are ridiculous again. Okay, fine. Did I need this? I guess so. Maybe I don't. Maybe that's why I'm getting it wrong, because this is not a good base case. Alright, I give up. Maybe not 100%. I just want to get a hint on the Q4. Let's give it a quick look. Ooh, still 3,000 though. But let's see what Josh did. Oh, sparse table. I mean, I did want to use a sparse table, but is sparse table enough? Oh, maybe it is, huh? That's true. But otherwise, everything else is the same idea I had, I suppose. Maybe I should use a sparse table. I heard that Geo also did it. Where's just Geo? Oh, there he is. Also sparse table. Yeah, maybe I should. I tried so much to use. Wait, he also did sig tree. I actually didn't know that sparse table would work for bitwise n, but for some reason I didn't really. I mean, the code is like roughly the same, so I don't think I'm off. I'm just like not debugging quite right. Yeah, because this is the same. This is like basically how I'm structuring mine. So yeah. So I mean, except I'm using sig tree instead. So I chose the wrong one, but still should be able to solve this though. Maybe I'm just a little bit off on this one. Maybe one more hint from Josh. No, he did binary search. I wanted to see if there was a quicker non-binary search way, but this is basically the same thing I did, right? Except for he's using sparse table. I don't know why I know why, because I spent an hour debugging sig tree, but using the wrong sig tree. But I think I mean, the complexity is a little bit worse, but should be able to do it. So I don't know. So maybe I do have to debug this a little bit more. Okay, fine. So this is the last element, right? Alright, maybe I do need this for the other thing, but we'll see how that goes. Yeah, okay, so it gives us 2. But it prints 0, which is way wrong. Oh, because it goes from 0 to n? What? Wait, what? what is this print? Oh, this is 4, 3. Oh, this is just this query. This doesn't really do anything, but oh no, it gives us the 0 so that we can put 2 here. Okay, that's true. So then why is the 3 failing to capture? What am I doing wrong? The 4, we have to 4, I mean we do reach from 1 to 3, which goes to 4, right? Am I doing something really wrong? I mean, yes, but okay, let's just keep this in here. This is infinity. What do we update? Oh, 3. What is going on? Index. Oh no, it's used. So this is used as 3. Right. Okay. I messed that up, but that's fine. And this is 4. Should give me 2. It does not. Why? Does it get updated later on? Do I like re-update this? I don't think so. 4.3, we're Gucci. 4.2, no bueno. 3.3, 2.3, no, I mean all this is fine. Why is it not? Am I just going nuts here? Is the default thing too dumb? No, it's min, right? Yeah. Index used 4.3. 3.4.4. So why is this not giving me the right result? I am not smart today. Also, I think I set this up wrong. I did set this up wrong, I think. Because yeah, I think I set this up wrong, because then now this binary search doesn't do anything for me. This binary search is to the left. So now I need to update the values. So okay, so then now okay, so then now we update. Okay, I think maybe now I get it a little bit. I think I messed this up. So best we queried, we don't query this. We actually update. How did I update that? Range update. Okay. I'm still I mean, if we get wrong answer, if we time out, we time out. But I'm still a believer of so far of my idea. I mean, I think my idea is right. I cannot get it to feel right, but you know, that is another story. I pasted another one where the range update is a set, so I could do something like this. So then now, okay, I think I got it now, maybe. I mean, I get the idea. Whether this is right is another story. So then now we want SMT update used. We want to update actually. So okay, so then best is equal to can we just I'm not putting stuff together I mean, like, I have to set up, but I'm just like missing the thing. It's very sad. So basically we want to actually, here we want to update because that's how far we can go. So then we want to do something like a range up. From range of good right to good left. Basically, if you start in any of those places, then yeah, then this is the answer, right? So we want to set something like this. But we have to set up the best now. The way I set this up is just way backwards, but yeah. But then best is set up by, it's equal to like num sub index, because this is the last index, plus used this is not +1, this is just used. It's this +1 dot query and -1 index +1. I think that's just the thing, and I guess the return value doesn't do anything actually, but oh well. So I can just leave it, even though I guess this is just wrong, just return best. Right, and this now doesn't, I guess it does stuff. Oh yeah, well. I like that how this is perfectly incorrect somehow, but okay, everything else is right. I mean, like the segment treat code that I stole. I mean, the thing is that even if I use a sparse array, it's the same thing. It's just that I'm not doing this part right. Like, I could just take them out. I don't think it's at this point, it's not an issue. So I have to really figure out like what is going on here. Well, I guess that would do it. I forgot to change this infinity to infinity. I don't think that changes anything, maybe. Yeah, it doesn't change anything. I updated this, but that didn't seem to do anything as well. Right. Is it n? No, this is n, not n minus 1. This is also of n, not n minus 1. The way that I've set it up. Alright, well, I mean, zeros are better than nothing. Alright, but we have this 2 that we wanted, 3, 3, 5. Maybe there's some stuff about 0 that we're confused about. Oh, that's just It's 3, 3, 5, right? 3 is index. This is used, right? So I don't think that's right. How do you even get a 5? Isn't this just infinity? This should give us infinity if it's index plus 1, index plus 1. Used my... Yeah, if it's not this, it should give us infinity, so I don't know. So this is giving us a number which is for the first time not right, but I mean, this update shouldn't change anything for that one. Let's see. Why would does this still gives us 5? Nope. So that's interesting, but why? Why is this giving me 5? What is, like, this update doesn't do anything for you. Like, why is use this n, that's right. Okay, fine. Okay. Okay. Why is this 2? Why are you giving me 2? We didn't update this. It's because I am dumb. I am dumb. Noob mistake. I mean, it's wrong here. Maybe we're off by 1, but oh my. Oh, Larry. Alright, I mean, now it looks like most things are right. I mean, there's still this answer, but we're probably just off by 1, which is, you know, way easier to solve than being, you know. Alright. Tell me why. I'm just trying to get rid of some of the print things. Where am I printing here? Up. Okay, so then now we have this case, which is the 4th case. 1, 2, 3, 4. So this one. Why is it giving me 10 instead of 12? Let's see. I was wondering what, like, oh my. I am not a smart boy today. Okay. Okay, focus for a second. 6 with 2 use, that's probably fine. 8 with 1 use is okay. But what did I put as the result is 10? How did I get 10? 2, 0. That's probably true. I don't think this is right. Query. How do I do it? Because 2 with 0 used, so that's not even right. That's not a possible state, right? So that means that this update is wrong, maybe. So, okay. I'm a little bit off on the base case. I think there's a thing where, because basically it's not reaching the beginning and it's still giving an answer, which is not right. But maybe this is just 0, 0. I'm going to reach to it. Okay, still wrong. Am I doing this one right? I think so. I've been making a lot of silly mistakes. Okay, so how do I still get 10 if I'm just searching for 0, 0? That was probably not. Oh, well, I mean, this updates, right? So this updates to the left and right. Okay, fine. So let's just do good left, good right, right. Back to. Okay, no update. And 2. Oh, if 2 is the last element, it can go from 0 to -1. That's, or -1 to 0. -1 to -1 to 0 is good left. Maybe my bounds are off by 1. But -1 to 0. I mean, you can't reach all the way through. That's why this is wrong, right? But how did this happen? What is the first user? Oh, first user 0. So okay, maybe it can now, cause 0 to 0. That shouldn't be right. What is -1? Oh, good left is -1. Well, left is -1. Oops. Let's see. So 0? Really? Oh no, left is 0. And then this thing is right, I guess? Is that true? Well, in any, maybe, maybe -1 just returns something funky. If, okay. It's still wrong, but at least maybe we're closer. No, Used is 2. Or used is 0. And now good left. There is a good left and good. Oh, well. Then now it doesn't update, so that's good. But, oh, does it? Do. Off by 1s. Alright, so this does get updated. Why? Is left positive? Just double checking my indexes, but okay, I print out the word left. Is that what happened? I might use a Western brick to be honest, but okay, left is 0. I thought it's -1. What am I printing? Oh, good right is -1. 0 is -2 and 3 and 1 should not be -1, right? 0 to index is 2. Why is that? Yeah, it returns 1. Am I like going nuts? I mean, yes, but I guess that's right. But why? Why is 0 2? Am I getting the index wrong? No, I mean index is 2 for sure. Why is 0 to 2? Is this am I having an off by 1 or a stroke? I mean that part is possible. Why? 1, 2, 3, and 2. Oh, it is 0, right? Wow, I am just like, yeah, because 2 and 1 is 0. Okay, yeah. I'm just being, wow, I am just combined. Okay, so it gives us 10 because you have 2 plus 8. So 2 plus, this is probably not, oh, yeah, because you have 4. So, okay, so I'm doing something weird where it's 2 plus 5 plus 3. And I've just been debugging something else anyway, so. Alright, so what are we doing? Why is that? Larry. Can we print things in the right order? Oh, this is no longer left plus 1. Maybe that's why. Well, -1. It should be, so this is the, yeah, okay. Maybe that messed it up. No, okay. If it is this, it's a little bit off. Oh, because we do it from, good left. Is the good left actually left? I'm so like dumb right now. Okay, so we want the first value that is, what am I trying to do here? We want the first value that is, okay, so if this chunk is less than or equal to, then we want to go to the right, so yeah. And then the first time, if it's equal, then we just set to the, right? That means that, yeah, if it's equal to, then you keep on going to the, if it's, yeah, okay. So then, wait, what? Did I mess this up? If this is greater than, I'm a little bit like confused right now in general. Okay. So let's see. Okay, if it's greater than, it's like a reverse double reverse for. So it's greater than, then we then we want to make it well, on the left side, we want to go to the left. So then we want to move to the right. Right? Why is this so weird? Okay. Right? Maybe we don't need the left for 0, 0. I don't know. This is just for printing anyway. Alright. And then now on this side, we want the left. So then now, if it is equal to, we want to go to the right, right? Wow, I have this backwards for some reason. As you go to, we go to the right. Yeah. If it's too small, then no, this isn't right. If what we have is too big, then we want to make it smaller. So we make it smaller by moving it to the right. No, so that's just, yeah, okay. And then now, maybe. Okay, so what is this 6? Oh, this, I thought it was 4. Maybe not, I don't know. The answer is pretty wrong though. What is this? So why is this left, right so wrong? No, because I guess this part is not true. Because this is not equal, this should be Okay, so left is 0, that's fine. Right? But then now 0, wait, 0, 6 is, did I mess this up? I messed up my, I cannot do binary search today. I've spent two, okay, so if the query, what we have is less than the value, we want fewer values by moving to the right. Oh man, how did I get this right? Come on. Otherwise we want more values. Because there's like a double reversal thing. That's why I'm like mad confused. Alright. So 5, that is right. Alright, finally, maybe. 0, 1, 2, 3, 4, 5. Okay, yeah. Like I think maybe we have to do a left +1 or something like that, but because this is the last value that is not included. But okay. Good left. And then now on this side, I think I have to do the same thing in not being dumb. Still dumb. Alright, somehow I fixed it for this case, but not anything else. 1, 2, why is this work? Oh, I guess 1, 2 does give it 3, but it doesn't give anything because it cannot reach the end. Okay. Oh no, the first case is right. So okay, so let's just, we already have it. Let's try again. But why is the other case is wrong? You have 2. So 0, 4, 3, 2, 2, 2. Okay, this is right. Alright, that's good. And then what about the 2s? 2s we have a 6, so that's good. What about the 1s? 1s no bueno. So the because Because this 6 is not updated. That's updating anything that we can find. That's why. Why is that? Index 1 is 4 with 2 left. Really? Or 2 matches used? That is just weird. I don't think that's right at all. What we should have is something like 4 2 or even 3. Oh, I guess this is right actually. 3 2 2 2. Okay, fine. 2 2 2 2. Okay, also. So I don't know that I'm updating the right things. That's why. Oh, I'm updating the values, but I should be updating the min. I think that's why. Because now it overwrites maybe? Unsure. Okay, but for 3 we updated 2 2 on the is the 2 right? At least the 2 is right, and then we want 1 of the 3 and then 1 of the 3, so this should give us something that's not an infinity. But the best is updated from this, right? And yeah, I don't know that this is the right thing. Good left, good right is how far we got it, but it's not even that, right? No, that should be right. Except what is the good left, good right here? 2 2, is that true? I don't think that's true. That's why it's messed up. 4 3, so you have 4. It doesn't go to 2 for 2, right? That doesn't make sense. That just doesn't make sense. What is going on here? What am I? I'm just stuck on binary search now, maybe. Which is actually even sadder. 2 4 is definitely. Oh, I guess 2 4 is 2, but the right side is not right. Okay, so that means this side is not right. Because this is left instead of mid? What is wrong with Larry? I mean, this is now wrong, but at least we know why. Just so many typos because I've been just confusing myself so much. Okay, so then now let's think about this. Let's have a think. All right. So then now we want to get the. Do I even need a secondary binary search? I think so, but yeah, okay. And now it should be the okay. So if the query is bigger or equal to, we want to make it smaller. It should be right? Oh no. I think it's this maybe. Let's try it real quick. Nope. It goes from 2 to 4, which is that what I want though? I think 2 to 4 is what I want for this case actually. Don't know if it's right per se, but yeah, and then now, well, now I actually have to, that's why I forgot that I fixed the direction, so hopefully this is a little bit better. It is not. Well, okay, I mean, we're getting somewhere. 5 and 5, this is actually what we want. And then this is also what we want, 8. And then now 1 0 is 12. Yes, that is what I want, I think. But Yeah, I mean, I think that's it, right? So now we can do this, maybe. Yeah. Nope. Why not? Isn't this... Oh, this doesn't update anything. Oh, is that right? This updates, right? But why is... So you had one... Why does that not update anything? One and... Am I further have silly debugging things? Wouldn't be surprised. Yeah, there's no update. I think this needs to update stuff to make it work. These things don't. I might have a bug with overlapping updates as well. So I think it's supposed to be set min, not just set or for the range update. But yeah, which I'll have to ask ChatGPT for it, but GPT for it. So at index 1, use of 0, which is 0. So what's 1 and 4? 1 and 4 is 0, right? So why not? Oh, is this +1? Maybe I don't need the +1. Maybe I would just... I kind of had it as a clutch, but... maybe I do need it. I don't know. Do I need a +1 in this one? Oh, I do maybe need a +1 on this one. But it doesn't fix this part because this is just not that, right? Alright, so then now this is 1. What is that huge number? Huh. That's not right. That just cannot be right, right? Left, 1 is the... What? Why? Oh, no, I'm looking at the wrong one. It's 130. What's 1 and 4? 4 is just 4, and 1 is... Should be... Why is it returning 3? Am I having a typo here somewhere? Left and index. I don't get it. I don't get it. 1 is 4. That's true. Am I looking at the right one? Did I just had a different thing before? Yeah, 1 left. I think this has to be -1. Maybe that's why I didn't really judge it right. Yeah, okay. I mean, it's still wrong, but maybe there's just a weird off by 1 as well as a result. Okay. 12, but then now this goes to 11 as a result. And it's going to be possible? I guess that's possible. Something is a little bit off from here. Because this thinks that it can be possible. But why? It is 11 because it's 3 times 8 because it updated itself or something. So it's reusing the same number twice. So maybe I'm just That's a little bit weird. So I'm using the same number twice. Okay, let's look at the updates on the 1. We update 2 and 3 with 8, so that's probably it. We're saying 3 and this. So, okay, what am I saying? Okay, I don't need this anymore. I was just being dumb. I also made this -1 as well. Alright, I was hoping that... No, I mean, I knew that one, of course, that didn't change this thing. Okay, so then now, even this is 11, which is not great. But how? Okay, because this updates to 2 and 3, which is true, I think. It's just that when you maybe the way I'm doing it is a little bit wrong. Because I'm trying to do it backwards, but I'm not. Maybe basically this is saying. Okay, how does the DP look? Right. Maybe that's a better visualization. Okay. Right. So this is saying okay. We update. Well, we have zeros for the really big one, right? But there's only 5. Yeah, I guess it's 6. And then this updates 2 to go up to all of these. That means that if except for the 1, I think, right? From 2 to 5, so maybe not, but oh yeah, because the 4 cancels it out. So then now you have 2, 2, 2. As to, if we start here, then the answer is going to be 2, right? Okay. I think that's right. And then could actually have just print this, but oh well. And then 3, 2, we have 5. It updates 2 and 4 to 5. Because it's 2 and 4, right? That's already kind of a smell, to be honest. I don't think that's right, because it reuses itself already, even in this case. I think this is wrong. But basically we're saying that am I? Oh, that's why, because this is the index and we go to 2 and 4, it doesn't make sense, right? What am I doing? Yeah, that's why it is wrong. Okay, okay. We figure out why, but why? Okay, okay. I get it. Why? Okay, well, I mean, this is because, do I still +1? Maybe not. Alright, I'm just being dumb, because it just went over the index, and then it double counted, maybe? Alright. I mean, this looks like it gives me the right response. Let's add this thing for the timeout purposes. maybe it prints two. No, I mean, it only prints like 5 things. Is it still time limit exceeded? No, we're finished. All right. I mean, I'll do it again with sparse array. It looks okay. Let's give it a submit. But I had this like very quickly, to be honest, but I just didn't know how to do sig tree correctly. Oh, I mean, that's. I mean, maybe I still have an off by 1, which is very sad. Also, we moved this case because this case is like very slow, and we know that we can handle long time limit exceeded now. Or, well, we can handle that case. I don't know if we can handle total time limit exceeded, but. Why do I return -1? Is this right? I don't know, but I am getting annoyed. Wah! Wah! Okay, so here's the last problem. Where's my... so close. I mean, we were close. Alright. What is the input? 1 in. So... So at 2 we have 8, which makes sense. We can also have 2 of them. Well, we have to have 2 of them, right? So at 2, if this is the last index value, we update 1 and 2. I think that's right. Yeah, for 8. And then here at 0, we just update. Oh, what? That is. I mean, that is maybe right, but doesn't fix it for us. I mean, that's definitely not the answer anyway. But why is this not right? Because they should give us. We update from 1 to 2. So why is this not right? Huh? Man, I deleted a lot of debugging things too. Alright. Oops. Let's put this back in here. Okay, but why? Alright, so that's good. So that's 1, right? That's at the... do I have an off by 1? So I remember... Oh, it's here a bit. So you should update 1 and 2, right? Why is this only updating 1? I mean, that's definitely a smell, even if it doesn't. You know, 0, 1, 2. Oh, it updates 2, but not 1. Why not? Why not? Huh. Oh, this is the bug that we were talking about, because another thing gets updated here and it overwrites it and I need to fix it. Okay, I mean, we knew this, but it's just been so long I've forgotten about it. Okay, let's see. Can I fix this without doing it? Range update. It's not lazy set, it is lazy min, right? Okay. I'll just ask ChatGPT. I mean, I know how to fix it, but can we update? Can we change the update range to set to update min? Yeah, apparently they just want us to copy this extra function. Okay, fine. We'll see if that works. No, I don't know. Can we change update range to min to set to update min? Oh, apparently I have 2 windows open. That's why it was giving me crazy stuff. Okay, now we're okay. Change range update to update min, please. All right. Right. I mean, this is actually shouldn't be that hard, but I can't think right now anymore. Anyway, I'm out of energy. I'm out of juice. Sorry, friends. Also a sec tree. Tell me why. Okay, that is silly. I mean, I knew that it was a thing, but if it times out, then we'll just do it again with sparse table. But that's fine. Which would be sad because then I'd still do it, but okay. Right. But I was using the wrong data structure, I suppose. I mean, I still think maybe we get away with it, but I guess Leetcode complexity. I mean, this is like, I don't know. I mean, it's definitely slower than we should like, but it is the same idea. The thing that we can do now is convert this to sparse table. Maybe let me see if ChatGPT can do it because I'm lazy. Can you convert this to use sparse table instead of sec tree? Right, we'll see if this actually is true. I don't know that this is. I don't know that I believe, you know, but it's better than what I had. But maybe I don't know. That's true too. Did they have my infinity value right? Oh, they still have my infinity value. That's good. All right, so this is the sparse table. Okay. All right, let's just give it a spin. I don't know. All right, one time ever because. Because of negative values. I was hoping that I can just not think about it, but I guess not. Is the rest of it right? I don't know. I'm just trying to make sure that this looks relatively okay. But I don't. Yeah, I don't know that you can do this though. But by the way, it doesn't seem to be working anyway. So. Why the negative shift value? What does this mean? Oh, J is negative? Huh? Alright, I'm going to cheat and see. Oh, Josh doesn't have. Just going to copy a. Oh, you could do it with DP. Good job, Chi-Chi. Is that why so many people got it? Huh. I mean, I did with. Well, you did with segment tree. I guess you could also just do it with like. Maybe I should just see if I can convert it to another language. I forgot about that. Oh man, I have to kind of like find the problem or something. Because I did it after the contest, I think okay, fine. Okay. I forgot that there's just so many silly things. Okay, let me see if I can convert this to Java or something. Maybe that'll be good enough for today. Can you convert this to Java? And is this the link? And then I'll see if I could understand Chi-Chi's. I was so stuck on this though. I mean, everyone seems to be doing it that way, so I don't know how Chi-Chi was able to do it. I mean, good for him. Oh no, it's too long. Oh no, there we go. There's a continue generating button. There's a lot of code. Okay, fine. Let's see if this works. I thought it would be fast enough, though, so I shouldn't be so. Like if it works, I would not be surprised, but we'll see. Line 163. Oh, there's a I don't know how to. Oh, because it's an anonymous function. But why did I say Java? Convert to C++, please. Maybe that's a little bit. I don't know. I am very annoyed right now, but then we'll learn something with. The problem is that with this one, I didn't really. I mean, like the thing with this one is that I knew how to do it, so I don't know if that's good enough, but it is what it is. Like I didn't have trouble with the algorithm. It's just I don't know. I don't know how to program apparently, which happens. All right, come on, let it compile. Oh man. Oh, this part. Yeah, okay. Something like that, maybe? No, this is an array of... No, it's a segment of them, right? But how does that even... Oh, no, that's fine. I just forgot them in C++. I mean, maybe it still gives me an error. Okay. What do you want me to do? Line 210? I think I needed this. I remember needing it. But why is it giving me an error? Oh. Huh. Okay, fine. That's weird, but fine. Oh, where is it? 167. Let's just make it long. Oh man, I should ask whatever to do whatever, but okay, fine. 167. Oh, wait. Okay, well, we got some answers right, but we got some answers wrong because we do not use long. What is the best way? Am I just gonna ask? Okay, convert all ints to long long. It takes so long for it to generate code. I'm gonna get a water while it's generating code. I have to click on continue gentlemen. I have to hope that it doesn't do anything stupid. Why do I have so many windows? Right. 232. Right, I don't have that code. I removed it. Huh? 148. Is it because this thing is wrong? Oh, this is actually an int, I suppose. I cannot convert those. Oh, I hate this. I guess this one is okay to be int. Yeah, whatever. I think it's just input anyway. 167. Do I have to... Oh no, just go in max. Okay, looks okay. See if it's fast enough. If it's not, I'll just cry. Alright. We did it, friends. This is ridiculous. Alright. I mean, I knew that's the sad thing, is that I don't think I learned anything. Other than... I mean, I did... It took me a long time to do it. And I was able to figure it out, but... and I did miss some insight, so it wasn't purely that I would have gotten it. But let's see what I did. Let's take a look. Let's take a look to see if we're learning anything, and we'll figure it out. Let's see. I didn't know that there was a DP. I mean, clearly I did not see it. Oh. Why is that good enough? What are the constraints on this one? I don't get it, to be honest. Let me think about it a little bit. I mean, clearly a couple of people did it this way, so it's possible to do it that way. No, I mean, the code is very simple, right? Like I don't mean it as an insulting way, but I just don't know how is that good enough? I guess I should have YOLO'd it if I wasn't doing anything, but how is that fast enough? I mean, all right, let's see if we could figure this out as an up south. Okay, fine. N is equal to length for thumbs, M is equal to length for n values, right? So then now we have, say, index, the use, the same as before, and then the current, right? And let's put in cache. Then if index is equal to n, then if used is equal to m, we return 0. Otherwise, we return infinity and beyond. And then now it's just tick no tick, right? So tick or not take no tick, that's not the right phrasing, but how am I doing this? So then now I just, no, I mean it is pretty much, you know, num sub index, right? And then now if index is equal to n values of used, then used plus 1 index, well, min plus num sub index, right? So something like this. Yeah, and then all is gonna go 0 0, something like that. Yeah, and then if we turn to -1, and then we turn out something like this, maybe. Is that what this thing will work? Well, okay, maybe not that. Did I get it wrong? Oh, this is wrong. Whoops. And then now this is infinity again. Let's just change the infinity value to, I could reuse it, but oh, maybe I have to be a little bit careful. I mean, I'm just watching it because you know, but I'm just confused how this can be fast enough. Huh, why is this fast enough? I guess I should have YOLO tried this, to be honest. But I mean, this is 10 to the 4th, this is n, but current, what is the bound on current? I mean, it is decreasing, but I mean, if I've got, I don't know. I mean, people, like, this is 44 minutes, right? So I had plenty of time to get something, but yeah, I don't get it. What is the complexity? Because it's going to be 2 to the number of bits, but it's only up to 10 to the 5th. Alright, what's 10 to the 5th again? 10 to the 5th is 100,000. So that's only 16 bits. Something like that, 17 bits. Right? But and then it does get smaller, but not in a how many possible, I mean, is it I guess so. I guess they would only could be like, that is, wow, I suppose so. There's only like 34 possibilities because you can't go left, go right, and that is hard to figure out. I've used this concept before, but I guess that was so, I mean, because it reminds me of a problem that I did a long time ago about like this delta difference. But wow, I mean, I guess that's how people got it. I was just so stuck on this. Yeah, well done, well done. I think I should have YOLO'd it a little bit though, maybe. Because even if I had gotten it at the very end, like I would have a lot of people didn't get Q3, so if I had just gotten Q4, I would have been, even if I was the last place, I would have been up like 100 people, which would have been nice. But but could I? Yeah, good job, Chi-Chi. Good job, Josh. Okay. Yeah, I guess so. That's interesting. That's an interesting path. Alright, well, I mean, I guess so. I just didn't really think, it just never occurred to me. So I did learn something today, but not this part, so yeah. Alright, that's all I have for this one. Let me know what you think. This is a bit of a disaster, but still 3,000, I think, according to the predictors, so because this has been so long. Let me know what you think. Thanks for watching. Give me a like. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this explanation, this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.